Hello everyone. In today's video we're gonna discuss the continuity and how we know that the function is continuous at a certain point or not. To know that the function is continuous at a certain point, we need to check these three conditions. So if we have a question about the continuous, or if I need to check if the function is continuous or not, I need to check these three conditions. Okay, the first one is about the value of the function. Is the value of this function defined or not? Do we have a value at this point or not? For example, if I have f of x is equal to 1 over x, okay, and I need to check the value of this function, is it defined or not? For example, if we are talking about the continuity at x is equal to 0, for f of x, if we substitute by 0, we will find 1 over 0, which is error or undefined value. So if we get undefined value when we substitute with the point, then the function we said that the function is undefined, therefore it's not continuous. So since the first condition doesn't satisfy, so we can conclude directly that the function is discontinuous at that point. So we don't need to check the other points. Second condition, we have the limit exists. We know that, or if we need to check that if the limit exists or not, we have to check the limit from both sides. So we can conclude that the limit exists only if the limit of the function when x goes to a from the negative side should equal to the limit of f of x when x goes to a from the positive side. So if we have this condition, then we can conclude that the limit exists. If we know that the first condition satisfies and the second condition satisfies, then we can go directly to the third condition, which is that the limit of f of x when x goes to a, يعني limit exists, will value defined, and they are equal to each other. Okay, so for example, if I have if the value of f of a is equal to 2, and the limit when x goes to a for the function is equal to 2, then since the limit exists and the value defined and they are equal to each other, we can say إنه الfunction is continuous because the first two conditions are satisfied and they are equal. Otherwise, for example, if I have f of a is equal to 2 and the limit is equal to 1 over 2, then the function in that situation is not continuous because the third condition does not satisfy. The first example, we have a figure, a graph here, and we need to check the discontinuity or the points where the function is continuous. So whenever you see the word continuous or discontinuous, okay, keep in your mind the third conditions, which are these conditions. Okay, so the first condition, the value at a must be defined. The limit from the right hand side and the left hand side must exist and they are equal, which means that the limit of x when of the function when x goes to a must exist. And finally, this value and this limit f of a is equal to limit of f of x when x goes to a. Okay, in other words, we can say that if the function is continuous, means that the graph is continuous. There is no holes, there is no limit, infinity discontinuity, no jumps, means that the graph is not cutting. So the first one, it's clear that we have a discontinuity here. Why? Because we have a hole. So what is the meaning of a hole? The hole means that the f of 1 is not defined. So we don't have a value. You can't see a value at x is equal to 1. So in this case, the first condition is not satisfied. Therefore, it's discontinuous. It's discontinuous because of the first condition. Okay, and then we have additional discontinuity at x is equal to 3. At x equal to 3, okay, if I need to check the 3 condition, the first one, f of 3 is equal to what? F of 3 is equal to this value. And I choose this value because it's closed. Okay? So, for example, the value is equal to 1. So, f of 3, is equal to negative 3, is equal to negative 1. So, f of 3 is equal to negative 1. Okay? So, the first condition satisfies, which is equal to 1. So, the value is defined, which is equal to 1. The second condition, where I should find the limit from the right hand side is equal to what? For example, is equal to 2. And the limit from the left hand side is equal to what? Is equal to negative 1. The limit of f of x when x goes to 3 from the positive side is equal to 2. And the limit for f of x when x goes to 3 from the left hand side is equal to negative 1. Since the limit from the right hand side is not equal to the limit from the right hand side, we can conclude that the limit does not exist, which means that the second condition does not satisfy. Okay? Therefore, it's discontinuous because of the second condition does not satisfy. The third one is this. Okay? At x is equal to 3, as x equal to 5. For x is equal to 5, again, I need to check the third conditions. The first condition, I need to find the value. What is the value of f of x at x is equal to 5? It's clear that it's equal to this, which is approximately 3. And again, I didn't choose this because it's a hole, and we said if I have a hole, then the value is not defined. So f of 5 is equal to what? Is equal to 3. Then the second condition, where I should find the limit. The limit for the function at x is equal to 5, I need to check from the right hand side and from the left hand side. And I can see that the limit from the right hand side is equal to the limit from the left hand side, which is equal to that value. Okay, which is approximately 1. We can say it's equal to 1. Limit when x goes to 5 for f of x exists, which is equal to 1, or approximately equal to 1. And I said it exists because the right hand side, the limit from the right hand side is equal to the limit from the left hand side. So the first condition and the second condition are satisfied. Then the third condition, I need to check, is this value equal to the limit? It's clear that 3 is not equal to 1, which means that f at L5 is not equal to limit for f of x when x goes to 5. Therefore, it's not continuous at 5 because of the third condition.